Let's now consider another example of a rational equation. You recall that the first step is to factor each denominator, and the only denominator that will need to be factored would be the one on the right-hand side of the equation. And the x squared minus 4 will factor into the difference of two squares. Now, before we consider finding the lowest common denominator, we'll want to determine any values of x that will make a denominator 0, which would make then the fraction undefined. These are the restrictions that we've talked about earlier. We can see that with the first fraction, the value of x that would make that denominator 0 will be 2. So we'll state then that x cannot be equal to positive 2. And on the right-hand side, we can see that negative 2 will make that denominator 0. So those are our restrictions. And keep in mind that if those values come up as possible solutions later, we need to reject them as being extraneous. Next, we'll determine the lowest common denominator of all the fractions. And by inspection, we can determine that that lowest common denominator will be 5 times the quantity x minus 2 times the quantity x plus 2. And what we'll do now is to multiply the equation by that lowest common denominator. Now, ideally, it would be best to put that lowest common denominator next to each fraction in the equation. But because of limited space, I'm only able to show it to the left of the equation. And what we'll do is talk about what happened when we multiply each term by that lowest common denominator. Now, with the first term, 1 over x minus 2, the only factor that will cancel with the lowest common denominator will be the x minus 2. So we'll be left then with 5 times the quantity x plus 2. And for the next fraction, the 1/5, the 5's will be the only factors that will cancel. And we'll be left then with x minus 2 times the quantity x plus 2. And on the right-hand side, all the factors will cancel, and we'll be left simply with the 2. So now we'll multiply through. Using the distributive property here, we'll have 5x plus 10 then. And multiplying the x minus 2 times x plus 2 will produce x squared minus 4, then is equal to positive 2. Now we'll combine terms and put them in standard form, and so we'll end up then with x squared plus 5x plus 6 then is equal to 2. And because this is a quadratic equation, what we need to do is to make one side 0. So we'll then subtract 2 from each member. We end with x squared plus 5x plus 4 is equal to 0. And so next what we'll need to do is to factor that quadratic on the left-hand side. So you can see that the x squared plus 5x plus 4 will factor into x plus 1 times x plus 4. And setting each factor equal to 0, which we can do mentally, we'll see that x is equal to negative 1, or x is equal to negative 4 as possible solutions. Now, since neither of those values correspond to a restriction that we stated earlier, which you'll recall were 2 and negative 2, we're assured, unless we made an error in our computation, that those are valid solutions. So there should be no extraneous solutions for this rational equation. Now what we'll do next, let's check one of those values, so you can practice doing that, then we'll leave the check of the other value to you for practice. Now you can see what I've done is to substitute negative 1 for x each place it occurs in the equation. What we'll do now is to simplify each side and hope that they turn out to be the same number. So for the first term, we're going to have 1 all over negative 3, then plus 1/5. And on the right-hand side, we have then 5 times, and then inside we're going to have 1 minus 4. And then if we simplify on the left-hand side, we need to find a common denominator, which we can see will be 15. So negative 1/3 will turn into negative 5 over 15. And 1/5 will become 3 over 15. And on the right-hand side, then we will have 2 all over 5 times the quantity negative 3. And so if we now simplify the two fractions on the left-hand side, we'll end up with negative 2 all over 15. And on the right-hand side, that becomes 2 over negative 15. And we know that those two fractions were equivalent, so we're assured then that negative 1 is a legitimate solution to the equation. And let me encourage you to practice checking the value negative 4 into the original equation as well.